Hello and welcome back to a new lecture in Basis and Practice in Programming. And in this lecture we are going to have a new topic for this week. So let's see what we are going to cover in this week. So before I'd like to go farther and start as usual what we are going to learn this week, I would like just to recap what we have learned so far. And maybe some of you ask a question, okay, we are learning programming language, but how we can use this programming language? What is the benefits which we can come at the end of this course? So just in the middle of the course here, I would like to say what we have learned and how we can use those concepts we have learned in the future. So we have learned so far how we can print on the screen, how we can read from the user keyboard, and also we learn how to save some data inside variables. And we learned there are many types of variables and we can use those variables to store some data. Also, we have learned some concepts like constant, like string, like Boolean values, true and false. Also, we learn about logics, like, for example, something bigger than other things, something equal to other things, something not equal to other things. Also, we learn about loops, like, for example, while loop, for loop, do while, and we learn that those loops to do some task several times. Also, we learn about branching. So we learn about, like, if there is some specific condition, run specific code. And if there is another condition, run another code. So this is what we call the branching. And in the branching, we learn about if-else statement, switch statement, and go-to statement. Also, so far, we learn about functions, how to create some procedure or some code, and this code we put it in a small block, and this block we call it function, and in this case we run this block several times by calling this function. Also, we have learned so far arrays, how we can create, save some data, not only single value, multiple value in one variable, and we call that variable array. And there are two types of arrays we have learned so far. We learn single dimension array. That means this array is just one row of values, multiple values. And all of them are from the same data type. And also, we learn how to create arrays of two dimension, like arrays which are very similar to table. Like there are many rows, and those rows like rows in a table, and you can save this data to save multiple values or save like table of data in one single variable. We call it two-dimension array. Then after that, we learn structures, and we said the main purpose of structure is to save some variables which are related to each other in a one block. We call those structure. So for example, we say like student ID, student name, student age, student GPA, student courses, all are related to students. So we can create structure of students and save all of these data inside that structure. So this is just a glimpse for what we have learned so far. And maybe we will learn today pointers, and maybe later we read more and more topics until the end of the semester. But maybe you will ask a question here. Why do we learn these things? How we can get benefits of these things? Okay, the first thing is that what you have learned here can be applied easily to any programming language in the future. So for example, if you would like to design some website and you would like to learn some programming language related to web, in this case, all the concept you have learned here, like function concept, loop concept, if statement concept, string concept, all of those concepts are available in the web programming language like JavaScript, for example. And here is an evidence just to show you this is true for, so for example, JavaScript is a one programming language for designing websites. So if you go here to the syntax or the grammars of JavaScript, I will just prove for you that there are some arrays. You see here, there are how to create arrays, how to create variables, how to create a string, how to create booleans, and all how to create functions, how to create logic like big, greater than, less than. You see, if statement is here, for statement is here, while statement, do while. So all the concept you have learned in C programming, you can transfer them to another programming language. That means for us as, for example, for me as a computer engineer, it was easy for me to learn a new programming language after I learned my first programming language. So the main purpose of this course is to let you know the concept of the programming language, and then in this case, and one example is the C programming, but you can transfer all of those concepts you have learned into a new programming language. So for example, this one is for web programming. How about for desktop applications? Like you create application like calculator. So like this calculator here, this is a calculator software. Can I create this one? Yes, you can do this one using something like Java. So in this case, let's go to Java programming. So Java syntax, and let's see if the Java syntax has the same concept or similar, not exactly same, but similar concepts like C programming, and the answer is yes. Look here, there is if else, there is a switch, there is while loop, there is for loop, there is continue and break, there is array. So all the concept you have learned, you can use them inside Java, and they are very, very, very similar to what you have learned in C programming. So learning a new programming language will be much easier if you successfully end and practice this course and learn all the concept well in this course in C programming, and then those concepts are easy to just update them or upgrade them to a new programming language. So this is, I can give you many examples of programming languages which are very similar to C programming, and they can do great things and very advanced things. Like for example, Python programming language, Java, and C, C++, all of them are very similar, and all the concepts you learn in the course, you can move them to a new programming language. So far, and this is why I mention or comment about this one, just to give you a feeling why we are learning these things. When we learn this concept, it will be really good for you in any field, even if you are not computer engineer, in any field. If you would like to create some software or program some software using any programming language your field is deal with, in this case, you can use the concept you have learned in this course to create software using a new programming language. Okay, so that was just what we have learned so far, and now let's go to the lecture of today. So today's lecture will be about pointers concept, and pointer concept is a very important concept in C programming to control memory and to control your computer memory and read from wherever you want in the computer memory. So it will be more clear when we start learning about these pointers later. Okay, so we will have introduction to pointers, and then we will see pointer operations, pointer arithmetics, and some overview about how we can use pointers for arrays and for other or for variables. And then we will learn more about advanced things about pointer arithmetics. Okay, so what is the pointer? So the pointer is just a variable, and that variable is a special type of variable. That variable, usually in the normal variables, you have, say, for example, integer count here. If you see this example here, you will have integer count, and that integer count has some value, and this value is 10. Okay, so here you will have this count at value 10. In the case of pointer, we will have, this is a pointer here, and usually inside this pointer will not be a value, it will be address. Okay, address from the memory. So before I go and speak what is the address and this stuff, let's have some let's have some whiteboard. Usually in your computer you will have this, in any computer even in your mobile, you will have something, we call it the brain of the computer, or we call this one the CPU, okay, or central processing unit, okay, central processing unit. So the central processing unit is the brain where we can do the math operation of the software, run software, do whatever operations. It's like the brain of the computer, this one. Okay, so the CPU usually communicate to save the data. For example, it's doing something and remember these things. To remember this thing, we have something else. We call it RAM, the computer or random access memory, or RAM, or we call this one the computer memory, okay? So the computer memory, the CPU save the data inside the memory and receive the data back from the memory. So for example, if you have a variable, say for example, I have integer count equal 10. For example, if I say like this. So when you say integer count, that means this is a storage, the variable is a storage. And this storage will be saved in the memory. So it will be saved by the computer, by Windows or your operating system. The operating system will save this count inside memory. So you will save here 10. And this 10 will be in a specific location in the memory, or we call this one address. For example, this is address 00000, and this address is 00000, for example, 4. Okay, this is the address. Where is this one? And you know, this one is integer, that means 4 bytes. So after that, if I say another integer, for example, value, if I say val 20, in this case, val 20 will be after this one, it will be 20 here, and this location of this one will start from location 000, and then now 4, because this one will take, so the address of this one will be 4 bytes in the computer here, 4 bytes for 10, okay? So those 4 bytes of 10 start from location 00004, okay? And then 0005, and then 0006, 7, and then the 20 will be saved in another 4 bytes in the memory, and those 4 bytes start from 00008, okay? Why 8? Because from 4 to 7 are used for this one. And from, so 4, 5, 6, 7, all of those addresses are used for a variable count, okay? Next variable will be starting from 00008, and then 0009, 00010, and 0011, okay? So this is hexa value, okay? So all of these one are used, so this one, the 4 bytes here, are used by val variable, okay? Then if you create another variable, for example, character. If you are creating character is just 1 byte, for example, C equal, for example, C, okay? So if you create this variable will be saved in the memory in 1 byte only. 1 byte start from which address? 0000, and then this is 10, 11, 12. So 12 will be C, okay? So this is 12. So C will be saved in the location 12, and so on, okay? So this is the, so every variable has some address. Where is this variable saved? So for example, so let's see this one together. If I go here to, for example, this one, Visual Studio here, and then I will create integer count, okay, equal 10. And then after that, I will print the address of this one. So I will say printf, and we learned about how to print the address before. So we will use modulo p. So modulo p for the address. Okay, so we will say modulo p, and then give me the address of count. So I will tell him here the address of count. Okay, where is the count is saved? So let's see. I will run this one, and we will see where is the count saved. So it's saved in this location in the memory, in my computer memory, okay? So in my computer memory, the address, this one is saved in this address location, Okay, now let's go and create another variable, integer, for example, val, and this one will be, for example, 20. Okay, and then I will print this one also. I will say print this one, and then I will make a new line, so it will be, and then I will print another one, but this one will be val, and let's see what will happen here. Okay, so just to prove for you that, okay, here is it. You see this one the count start from this location, and the last value is 4. So the next one, because this one, the variable will take 4 bytes, then the next address will be after 4 bytes more. So after 4 bytes more, the address will be 8. You see here, this is 4 and this is 8, and everything same. Okay, so this is the address as I explained in the slides. Okay, so this is how you can. Now, what is this one related to? Why you are, maybe you will ask why I'm speaking this story. Now the story here, this is because I have here the pointer. When we create pointer, usually the pointer start by star here. Okay, so there will be integer, and this is the name of the pointer, and there will be some star here. So this asterisk here for telling you that this one is a pointer. And then what is the value of the pointer? The value of the pointer will not be value same like any variable. So usually the variable, normal variable, has a value, okay? But the value of the pointer will be address. It will be address of another variable. Okay, so that means I will put here, I will say this is the pointer, okay, and the value of the pointer will be address of another variable, count. So what does this one mean? That means I will create int pointer, and this int pointer will point to a new variable count. So it will point to the count variable. Why it point to the count variable? Because here will be the address, the value of the pointer will be the address of count. Okay, so the address of count means it's pointing to the count. So this is why we call this one pointer, because it will point to where is the variable exist. Okay, so this is how you can say about this pointer. So we say this pointer is point to count variable. Okay, so usually, again, this is the general things. So the pointer will be, you will say what is the type of the pointer. Type of the pointer will be mean this pointer point to what kind of variable. This pointer point to integer variable. This pointer point to character variable. So for example, if I say here, for example, if I have in the memory, in the computer memory, I have integer a equal 20. So a will be 20. Okay, so a is a 20. Then I need to create pointer. I want to create a pointer, ptr for example. This is a pointer. I want this a pointer to point to a. If I want it to point to a, that means a pointer must be pointing to integer data type. So I would say like this. I would say integer star here, and then a pointer. Okay, and then this one I would say a pointer. Oh, a pointer is equal the address of a. That means it's pointing to a. Okay, so here is it. Here is another pointer. So this is pointer point to integer data type. This pointer point to float data type, and so on. And even you can create pointer which point to nothing. Void. That means I don't know. So maybe later I will decide what this pointer point to. So for now it's void. That means I don't say where this pointer will point to. Okay, so this is, we will see this one later. Okay, so in your computer you have usually, if your computer is using, for example, Windows 32-bit, in this case the maximum memory of your computer is 4 gigabytes. 4 gigabytes, why? Because the address of the memory will be only 32 bits. If the address is 32 bits, that means the amount of bytes available in the memory will be 4 gigabytes. Okay, but if your Windows is 64-bit, then in this case, the maximum RAM memory in your computer could be 16 exabyte. So 16 exabyte mean why? That means because the address will be 64 bits. So what I mean by this one? I mean that each location in the memory has address. And this address of this location in the memory, this one in the case of Windows 32-bit, the address will be only 32-bit. The address value will be 32 bits, okay? The address of this location, okay? And in this case, you will see the memory address will be 32 bits. So let me just show you how we can see the memory address of our computer. If I go here and then I just click on this one here, double click, it will be a red point here. And then after that, if I click run, okay, after I click this one, just double click here, click run, I want to see the computer memory. Now, to see the computer memory, just go to the debug and then go to window and then say, I want to see the memory of the computer. My computer is 32-bit Windows. In this case, you will see the memory has address 32-bit. Here is the memory of the computer. So let me just, okay, I can take this one out and, okay, here is the computer memory. And if you see here, this is my computer memory. And if you see here, this one is the address of this area. So this area contains value 24, and this is the address of this one. What is this one? This is address is a hexa value, hexadecimal value. So this one is 4-bit address, so 4-bit plus 4 plus 4 plus, so 4, 1, 2, 3, 4, 5, 6. 6 here, 7, 8, okay? 8 times, so 8, so this is the value of the address. The address is this one. So this address is 8 numbers. Each number is 4-bit. Each number is 4. So 8 times 4 will be 32. Okay? So this one will be the address of some location in the memory. So let me just show you. So here, this is, imagine this one will be something like this one. So here is the address of this location. So this location contains value 24. Okay? And next one, for example, next location will be, this one will be next after A, there will be what? This one will be the same address, and this one will be P. And this one will be including some another value, for example, this value. Okay, so this one will be here, for example, and so on. And we continue. So this is, so the address here is only 32 bits. Why? Because we are running 32-bit Windows. If we are running 64-bit Windows, in this case, this address will be not only 8 characters here. There will be something like this one. So I will show you. I will stop this one and I will say, imagine this software will run in 64-bit computer. If it runs in 64-bit computer, let's see how the memory will be. Okay, I will run and let's see the memory. Okay, you see, now the address is very long. Okay, so this address has how many number? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 times 4, it will be 64. So the address will be 64. Okay, so the address here will be very long. The address is very long. Okay, so this is the meaning of this one. Now, if the pointer is pointing to an integer, in this case, the value of the pointer, the value of the pointer could be, 32 bits, or the value will be 64 bits. Okay, so this is the address of this one. Okay, so to prove this one for you, what is the size of this pointer? So this one is a pointer, and this pointer is pointing to A. So you can make this one just one line, or if you don't want to make this one line, you can make it like this. Just this is like this, and then you say A pointer equal the address of A. Okay, so this is the pointer is pointing to a variable. It's pointing to a variable. Now after that, I ask, what is the because a pointer is just the value of the pointer, how much the pointer will take. The pointer will take how many, the address size. So if the address is 64 bits, that means 8 bytes. In this case, sorry, it will be 64 bits. Yeah, if it's 64 bits, that means 8 bytes. In this case, this one, the size of this one, if I run in the computer 64 bit, in this case, the size of the pointer, that means the size of the address, where the pointer contain the address inside the pointer. If you see, the pointer has address here, okay? The pointer has address, and this address could be 32-bit or could be 64-bit, okay? So in our computer here, we can say 64-bit and run. Let's see what will be the size of the pointer. So the size of the pointer is 8, okay? Now let's run again and change this one to 32-bit. So I change this one. I say, imagine my computer is 32-bit, so run. What will be the size of the pointer? And it will be 4 bytes. 4 bytes will mean 32 bits. So the size of the pointer will be depends on the memory setting of your computer. So if the computer is 64-bit, this one, the pointer will be 64-bit, the size of the pointer. If it's 32, it will be 32. Okay, now if this pointer is pointing to character, so imagine this pointer is pointing to some character. Okay, so if this one is a character, okay, so let's say this is character, for example, A, and this one is pointing to character. So now it's pointing to character, and you know, character is just 1 byte, but this one is pointing to this character. It's pointing to the address of this character. So let's see, is this one will be 1 byte? And the answer is, let's see the answer here, no. Why no? Because the pointer all the time, the pointer is address. I don't care if this address is address of a character or address of a integer or address of float or address of any type. So the pointer value is address. So the address will depend on the memory setting. So if your computer memory is 32-bit, the address will be, the pointer size will be 32. And if the address is 64, the pointer will be 64. Okay, so I hope this one is clear about pointer. So far, we have learned about how to define pointer, and we learned what is the value inside the pointer. Okay, now the pointer has some operations, like how to create a pointer, how to use the pointer we will see now. So how to use the pointer, and then also how to assign some value for the pointers. Okay, so we will see this one all during this lecture. So let's start by the first example here. In the first example here, I have some count. Count is equal 10, and we have another one is x. And then I have here a pointer. I create pointer, and this pointer is pointing to count. So the end pointer is pointing to the count. Maybe some of you will ask, okay, we did not know where we use the pointer. Just wait. We will see where are the main use of the pointer. So there are many places where the pointer is very, very important. But for now, we are just learning how to define the pointer and how to use the pointer. That's it. Okay, later we will see where we can use it. I mean, practical use of the pointer. Okay, so here, so let's see this one, this example here. Let's open this one here, and then I define. Okay, so based on this one, I will define count, and then I will make this one point to the count, and we will see. Okay, so I will have integer count, for example, and this one is equal to 10. And then after that, I will create some pointer with type integer because it will point to that count. So I'll say, for example, this one count pointer, PTR. Okay, so this is a count pointer, and this one equal the address of count. Okay, so this is pointing to the count. Okay, I'll make it 1 line. If you want to do it 2 lines, it's up to you. Now after that, let's see something we call it dereferencing. What is the dereferencing? I will say here star, okay, count PTR, okay, count. Now same, look here. Oh, I prefer here, it's just to this one. I will change this one a little bit, so just to tell you how to distinguish. Okay, look here. When you want to give value for the pointer, you will say count is equal the address of the count. So the count pointer is equal the address of the count. But when I put here star, count pointer is equal 20, for example. What I'm doing here, I'm doing something, we call it dereferencing. Okay, so the dereferencing is what? This one, let's see what is this dereferencing. Here I will say printf. Okay, printf, and then I will print here, for example, that what is the value. I want to say what is the digit value of something. Okay, so what is the digit value of count? Let's see what is the value of the count here. Okay, and run. Let's see what is the value of count. You must ask, oh, it's 10. Oh, it's not 10, it's a 20. Why 20? Because the pointer count pointer is pointing to count. That means when I am doing like this, I am controlling the value of the count. So it will be something like this. So you will have, here is in the computer memory, so you have the computer memory, and you have count here, the address of count, and this count, for example, the address is 372117, for example. Okay, this is the address of count, and count has value 10. Okay, then after that you create another pointer, we call it count pointer, count PTR. Okay, and this count PTR will have the value, address value of this count, so it will be 372117. So this is the value of the count. That means this guy is pointing to this one. Then after that, when you are doing this operation star count PTR, that means I am saying for the count, the count pointer, I'm telling him change the value of the count. So I am indirectly changing the value of the count without running this sentence, without saying, for example, like this, count equal 20. I don't do that. I don't do this one. I am doing this one using this one. Okay, so the pointer will indirectly modify the value of the pointed variable. Okay, so this is here. Now, if you also this want to change the value of the appointed value, if you want to read the value of the count without saying here print count, I can read the value of the count using this way. I will use star count pointer. Again, yes, again. This is for reading. So this one means read what is the value of the variable I am pointing to. Read the value of where I am pointing to. So let's see if this one is a 20 or not. Yes, it's a 20. You see here, it's 20. So what does this one mean here? This one mean you can read and write. If you put the star here on the pointer, you can read and write to the pointed variable. Okay, so this is one of the main important things for the pointer job. Okay, so the pointer will modify the variable the pointer is pointing to, and also it can read the value of the variable we are pointing to. Okay, so this is what we call it dereferencing or indirect modification of the variable. Okay, so this is, I hope it's clear. So for example, let's see here, I clear this one. This is another example. If I create here some integer I1 and I2, and then I create pointer 1 and pointer 2, and then that's okay, and I modify, so I create two pointers here, okay? And then after that, I will give value to I1 and I2. So I1 and I2 have some value. Okay, so let's see. I1 has some value 1. Here is it. Here is the memory. This is the computer memory. Imagine this is the computer memory, and I1 exists in this address. Okay, so I1 is available in this memory location. Okay, this one, imagine this one is 32 bits, very long, but to make it very nice for you to read, so I make it very small here, just to make it very easy to read for you. Okay, so this is the address of the variable I1, and it has value 1. This is the value. Okay, value 1. Let's go next. I2 has the value 2. So here is it, the value 2, and the variable I2 exists after 4 bytes location. So after 4 bytes, it's available in the location 1004. This is 100. That means 1000, and then 1001, 1002, and 1003 are all for I1. Then 1004 is for I2. So 1004, 1005, 1006, and 1007. Those 4 bytes are reserved for I2. Why? Because I2 is 4 bytes. Okay, so this one 4 bytes, and this one is 4 bytes. Okay, I hope this one is clear. Okay, then after that, let's see here. I give value for the pointer. So this is giving value for the pointer. So I say the pointer 1 will have the address. It will point to I1. So here is it. Pointer 1 available somewhere. It's available here, for example, and it has the value of, so this is the value of I1. So you see here, pointer 1 is have the value of I1. Okay, the value means address. You see the address. Okay, the value of the pointer is the address of I1. So this is the address of I1. Okay, I1. Okay, and then now next is pointer 2 has the value. Oh, wait a minute. Pointer 2 has the value of pointer 1. Okay, so pointer 2 has the value of pointer 1. Okay, that means both of them are equal. So that means both of them are pointing to I1. So they are equal. I'm saying pointer 2 and pointer 1 are equal. So pointer 1, whatever the value of address of pointer 1, give it to pointer 2. So the pointer 1 value is 1000. So pointer 2, the value will be 1000. And this 1000 is what? This 1000 is the address of I1. So that means pointer 2 is also pointing to I1. Okay? Then after that, now the dereferencing. Dereferencing is here now. So the dereferencing here say pointer 1, so there, what does mean this one mean? This one mean pointer 1, PTR1, and PTR2, both of them are pointing to I1. Both of them are pointing to I1, and I1 contain one value. Okay, so there are 2 pointers point to the same variable. That's okay, no problem. And then now I say pointer 1 dereferencing, the dereferencing of pointer 1 equal 3. That means this 3 will go to where? This 3 will go to where it will go as a value to where this pointer is pointing to. So it will go here and change this one to 3. So that means this one here will be changed to 3. So let's see. Yes, it's a change to 3. Okay, let me clear the screen. Okay, so it's a change to 3. Then after that, I say whatever pointer to value, also this one is value, because there is a star here, dereferencing. Okay, there is a star pointer 2. So pointer 2 is pointing to I1. I1 value is 3. I1 value is 3. So the 3 value will go to I2. So I2 now will become what? I2 value will be the value of where is this pointer is pointing to. So it will be 3. So let's see. It's a 3. Okay, so this is 3 here. Okay, so I hope this one is clear. So what we learned from this example, how to use to assign value to dereferencing and how to read the value of the dereferencing. Okay. Here is another one is to use the value of the pointer is C is meaningless until it's set pointing to something. So the pointer will be meaningless until it points to some variable. Okay, now let's see here what will happen. If I say integer pointer, okay, I will say integer star pointer, so I'm creating pointer P, and then here I say the dereferencing of the pointer will be 4. Where this 4 will go? You did not tell this pointer is pointing to which variable. You did not say. You did not say pointer P is pointing to the address of some variable. You did not say that. If you did not say that, in this case, in this case, you will have trouble. So this 4 will go to where? This 4 is a value. This value, because this is dereferencing, this value must go to some variable. But where is this variable? You did not do it. So in this case, this one will have some error. So let's see this one together. So I will show you how this one is working. Okay, so let's see here. I will create some pointer, okay, and then I do not give anything. And they say here, just go this pointer, create some pointer, and then after that, the value or dereferencing of this pointer receives some value 20. So this one will go where? So let's see. You see, it's uninitialized memory. So this one is not initialized. Even can we do the same thing? So they say, I don't know, where is this pointer? So if you want me to give this 20 value to some variable, where is this variable? I don't know, where is this variable? Okay, so because the pointer is not initialized, we did not give address to this pointer. Okay, so can we do the same thing in inside code blocks? So let's see here. I will run, and then I will. Okay, so here you see there is here message, warning message, say counter pointer is not initialized. So he give warning at the compile time. Let's run. Okay, so I need to stop my. You see there is some error. Okay, runtime error. There is something wrong. Why? Because of this warning. So usually you must look here to the warning. So usually the warning tell you there is something, there is issue, and this issue will generate some runtime error later. Okay, so usually you have to look to the compilation process here. If the compilation process say there is some problem, in this case you need to go and fix this problem before you run. But sometimes this warning is not critical. If it's not critical, the software will run no problem. So warning mean not error. Warning mean be careful. This is something might generate some error in the future. Okay, this is the meaning of the warning. Okay, so this is mainly for the pointers. So I think here let's see this one, this example, and then after that I will stop this video and then we will continue next video. So let me just see here, what is this one? Here I'm defining some variable. This is another example, and I'm defining another example, and then here I say now I'm creating some pointer. This pointer point to this pointer point to int one. So this one is pointing to this guy, and then pointer 2 is pointing to this guy. Okay, that's good so far. And then after that, I will say, oh, there is dereferencing here. That means give value. So I'm saying here, for this guy, give some value. Give some value. I'm giving value of what? I am giving address value. I am giving address value. Okay, so I say here, give value. This star here means give value. I give value. What is the value? I am giving value of int ptr2. What the value of the pointer, always the value of the pointer is address. All the time the value of the pointer is address. That means I am giving the address of this one to where is int ptr1. Int ptr1 is this one. So that means here there will be some address. This one will change to some address. Then after that, let's go to the next one. I'm saying here int ptr1 is equal int2. Okay, so I am giving here some value of int2 to int ptr1. Okay, I'm giving this one to int ptr1, and in this case this one Here he will give you, this one will give you warning, tell you be careful, you are giving some address. If you want to give the value of PTR2, if you want to give the value, in this case you must put here some star, okay? If you put some star here, in this case you will go to the where is this pointer is pointing and give the value to this one. So this pointer 2 is pointing to 8. So in this case 8 will go to here. To what? To what? To int PTR1. Int PTR1 is pointing to int 1. That means this one will be 8. If you put this star. If you put this star. Okay? But if you don't put this star, he will put the address of the pointer inside where is int 1. Okay? Inside here. Okay? So this is very important. Here, int, so if we say star int PTR1 equal int 2. Int 2 is 8. So the value of int 2 will go to where is this pointer is pointing. So this pointer is pointing to int 1. That means int 1 will receive value 8. Okay? So 8 will go to here. That means this one 8 will go. That means this 8, okay, this 8, this one 8 will go here. And this 8 will go to, oh, no, sorry. Okay, this 8 will go to int 1. Okay? So here, what happened in this situation? In this situation, I have, okay, this one point to here, and this one is point to here. This is good. And then after that, I say int PTR1, wait, this one means receive address. Int PT, there is no star. This one receive value? No. This is wrong. Okay? This is wrong. Why? Because I cannot give value to address. I want to give address here. So if you remove this one, that's okay. But if you don't remove this one will give warning. They say you cannot give value. This is value. Star mean value. So you don't give value to the address. So this one address. So you must remove the star. So there is some golden rule here. If you have a pointer, so if you have a pointer here and the pointer here, they must have the same situation. So if this one has no star, this one must be no star. If this one has a star, this one must have a star. Okay? How about this one? Is this one is okay? Yes, this one is okay. This one is fine. So here I say int PTR2, wherever the address of int PTR2, okay, where is int PTR2? So will go to the int PTR1. That means int PTR2 and int PTR1 are pointing now to the same variable. So after this line, int PTR1 and int PTR2, both of them are pointing to int 1. Both of them. Okay? So this is the meaning of this one. So this one has a problem? No, this one is fine. Why? There is no star here, no star here, everything is fine. If there is a star here and there is a star here, no problem. But no star in one and there is a star in another, there is a problem. So be careful about this point. Okay? Okay, so that's it. So far we have learned how to create pointer. We learned about how to give address for the pointer, that means value for the pointer. And also we learned how to make dereferencing. Dereferencing means make the pointer star PTR, and in this case this one will be the value of where this pointer is pointing to. So I say this one is equal to 20. So whereas this pointer is pointing to, it will be 20 value. Okay? Or I can say reading. For example, I say print f. And then I say, for example, here some digit, modulo D, and then I will say here, print star PTR. In this case, where is this PTR is pointing to, I will bring the value and I will print. So this is reading the value of the pointer, reading the value of where the pointer is pointing, and this one assign value to where is this pointer is pointing. We call this one dereferencing. Okay, so this is what we have learned so far. I will stop here and I will go and continue in the next video.